So here is liquid nitrogen. With some observations. You can see it's beating and gliding across the surface. This is negative 453 degrees Fahrenheit, I believe, something close to that. Maybe negative 423. I have to double check on that. Here, I'll get a look into it. There you can see it's boiling.
Alright, so maybe tea kettle.
Okay, here's a tea kettle. We're going to pour some liquid nitrogen into the tea kettle. Think about what's happening to the molecules of the liquid nitrogen that is turning into gas nitrogen. Maybe comment on the pressure inside the teapot. Why it's whistling. Notice it looks like maybe some vapors are falling. Oh, it even looks like maybe something is liquid that is dripping. Not water, because it's not leaving a mark. Maybe some sort of a gas that has condensed. It also looks like maybe there's some deposition on the tea kettle. Okay. Yeah, you can see as he rubs the glove, you can almost looks like snow or frost has built up. But we never saw it in liquid form, so it must be some form of deposition. Okay. Next, the tea kettle.
Maybe
And then flowers. So flowers typically very soft, bendy, flexible, living cells. Somewhat fragrant, but you can see here they're soft, bendy, slightly fragrant. These are living cells. So when you take them out of the liquid nitrogen, you can hear it's brittle, it sounds like glass. Popping really. What's happened to the flower molecules in the water inside the flower? Because flowers do consist mostly of water. It's also much more fragrant right now. I can very clearly smell the flowers.
and listen to the sound.
Still, teapot's still going. You can see quite a bit of buildup of that deposition. Even more around the pot. There we go. Very good. We also have a latex glove somewhere in there. Think about, you know, typically that was a stretchier, more elastic material. Kind of like skin. And we'll look at what it does after we cool it in liquid nitrogen. And the one in the liquid nitrogen. And here already, it sounds brittle. Easily crumbles. Think about the molecules, why that was possible. We have an ordinary racquetball. It's hollow inside, has air in there. Also bouncy. What happens when we freeze it in liquid nitrogen? And Mr. Harris is going to throw it at the ground. Listen carefully and watch how that once elastic ball with air in the inside, see what happens with it. It pops and breaks into many pieces that kind of sound like glass. So much more brittle. What happened to the molecules? Why did you hear that pop? Think about the air inside of the ball being exposed to the negative 400 something degrees Fahrenheit and what that gas condensed, and then maybe how that changed the pressure inside the ball, and maybe how that created the pop. And this is a bimetallic strip. See, it bi meaning two, metallic meaning metal. It's straight, but each side of the strip has a different type of metal. And when you stick it into liquid nitrogen, because they are two different metals and materials, one of the metals is going to respond differently and contract differently than the other. Think about what the molecules are doing, or particles are doing, when they get cold and lose thermal energy. And you can actually kind of see that it's losing a little bit of its curvature as it warms up. So think about maybe if we heated this, what might happen instead of cooling it. Okay. We have balloons. Now this cooler could probably fit 2 balloons maybe of that size. Maybe 2, not even 2. But you know, balloons are filled with air, which is a gas. And gases fill up their container, right? So here we're gonna cool them. And when it's cooling, think about what's happening to the gas inside, which enables us to fit multiple balloons inside the cooler. And that air inside the balloon condenses so much that it can actually turn the air inside the balloon into the liquid. I think the last, yeah, so we got 6 or 7 balloons in there. And then when you take them out, they gain their thermal energy again, so they gain kinetic energy in motion. And let's see if we can see that liquid in the bottom. Definitely can see the falling vapors. Oh yeah, yeah, you can see that liquid sloshing around in there. That's the liquid air. And now it is evaporating. The boiling, evaporating in there. And taking aside the container again. And the last one we have to show you is the shooting cork, which, you know, we're gonna pour. We have a little contraption over here that has a tube, and the corks fit in the top. And we're gonna pour some liquid nitrogen in there. Think about pressure maybe, the phase change occurring. Whoop, that was fast. How that is changing the pressure of the nitrogen gas inside the tube. And why it is able to launch the cork into the air. And that concludes our liquid nitrogen demonstration. Make sure you fill out the note sheet thinking about the molecules, their gaining or losing kinetic energy, their motion, their cohesion and amount of traction they have for one another, any phase changes that are occurring, how they're colliding with the surface and each other, and the pressure, and why we might be seeing the results that we are.